Everybody, this is a quick little video I wanted to throw together, kind of show what I was working on the last week. Over the past, I guess, almost year, I've been buying old Doble F series test sets, all broken, and the goal was to put together a relay test set that would handle three-phase testing of relays. So what you're looking at are three F series, two F2500s and one F2000 or 2200 I was able to get working, and these guys comprise a three-phase test set. The challenge was getting software to actually run them, so that's where Labview came into play. Basically what I did here was created my own state sequencer or test set, which allows you to specify the sources that are going to be used, currents, voltages, phases, and up to 20, I believe, minimum steps. And you can save off a complete sequence or recall that complete sequence. And options include external triggers to move to the next state, timed triggers, combination of external or time, or a stop which will pause or end the test sequence. So let me show you what we've got hooked up here. This program I was able to get probably 99% up and running over the July 4th holiday. A lot of nice little fancy things I'd like to add to it, but it does seem to work fairly well. Over here we've got a Debian Linux box, two copies of Minicom that are running, and what we're doing is looking at the serial data that's being passed to and from the Doble's test sets from our Labview program. The left side shows the communications that is going to the Dobles, and the right side is the asynchronous response from the Dobles, which kind of made the program a bit challenging because the Doble at any time could communicate back to the calling program, and the calling program may need to respond. We've got the quick set accelerator from SEL, Schweitzer Labs, set up here. A little teaser here of a quick assistant event viewer, and then let's look over here. And what we've got set up is an SEL 421, and we've got this SEL set programmed to run as a instantaneous phase over current protection trip. We've got a sequence programmed in that starts off at around, I think it's 10% line load, and we increase the loading up until 110%. And that is actually coming over here and going into a breaker simulator, and you guys have to love that collection of banana plugs. What this is a Koyo PLC, and it is functioning as a breaker simulator, and internal to it is an interposing relay, so we're able to simulate both the trip coils, closed coils, 52A, 52B contacts on a breaker. And then we've got some adjustments, things we can do like the delay trip time, and the actual whether we want to block trip or change whether we trip or close delay or trip only. So this entire process right here, and we're getting ready to run one, is set up to execute a sequence. As I've mentioned, we programmed. We're driving and have programmed the sense inputs so that when we reach a certain state which has been programmed to move to the next event by an external trigger, we have generated an output in the RS-232 line, if you will, which will come along and set that up, and when the breaker is tripped by our 421, the 52B finger will pick up. That is tied over here. Sorry for the camera jiggling all over the place. It's a handheld phone. That's tied to the sense elements, and that's going to advance these Dobles to the next state, which is a post-fault state. So let's go. We're all set up. We've got the units configured. So let's run a test. There's our first event. We're at 50% line loading, not 10%. I apologize. I told you wrong. 75% line load. I'm going to try to get the 421. We're at 80% line load now. You're going to hear a beep here very shortly when we go into the sense mode. And we're at 90% line load, and there we go. We've just tripped. You'll see phase A, B, C, and a 50 for phase over current. Breaker is now open, and if we look, we'll see we've moved to the last state, which is 0 amps. So that's our post-fault state. We've generated a bunch of messages over here that has come back. Let's put an end to that. Sorry about the long-term noise that's coming out of the thing. I can't get the banana plug in free. There we go. And in essence, what we've done is proven the Labview program and the 3 Doble sets here will actually function quite well. I've used an Omicron before, and this thing works pretty darn close to almost the way the Omicron worked, at least as a state sequencer. We have a lot of work to go. The goal is to ultimately do reclose simulations. And that's going to be quite interesting to go through first, second, and third shot on some reclose examples. And what we have over here is the actual, we ran this test earlier, this is the actual output zoomed in. And you'll notice, strangely enough, we can't actually see, we'll go back and do this. We can see here where our input 101, which is our A finger, we can see where that dropped out. But notice output 101, which is our trip output to the breaker simulator or the trip coil. You notice there was about a 5-second delay before we actually tripped the breaker or the breaker simulator. That was by design because we have set in here multiple trip delays. And we had this thing set up for a 5-cycle delay. I have to trim the PLC code slightly. This is more like around 5 3/4 delay for the actual delay that occurred for the trip before the A finger actually showed the breaker opening. And by the way, this thing will also do MOD simulations. We've got a 5-second delay that we have built into that too, and all of that is programmable if we choose to do so. So there we go. We can see where the Dobles were moved into the post-fault phase, which was 0 amps, 0 currents, and we have proven the system out. The really cool thing about it is there's not a whole lot of money tied up in these Dobles. I think actually I paid more for shipping on them than I did the actual units themselves. And we've learned a lot about them. Very, very interesting devices. A lot of features that are built into it. This manual right here goes into some pretty cool stuff. And what it used was a language called Doble Call or Doble Call. I'm not sure how they pronounce it. And in the very back is a list of all of the commands that you can send and the expected responses and what have you. A lot of interesting experimentation to get the Labview program to accomplish what it was with the Dobles that we wanted to accomplish. Hope you've enjoyed it.